Alexander Fleming was born in rural Lochfield, Ayrshire, Scotland, in the summer of 1881, where he lived on a farm with 7 other siblings. His father passed away when Fleming was only 7 years old, leaving his mother to run the farm. In his youth, Fleming attended local public schools up until he followed his eldest brother, Thomas Fleming, who was a practicing physician, to London at the age of 13. Alexander finished his basic schooling at Regent Street Polytechnic and then briefly served in the Territorial Army from 1899 to 1902. Shortly following, Alexander won a scholarship to attend St. Mary's Hospital Medical School in Paddington, London, where he began his medical studies. During his time in St. Mary's, he was awarded the 1908 Gold Medal as a top medical student. While Alexander had originally wanted to pursue a career in surgery, he took on a temporary position in labs of the inoculation department at St. Mary's. What was meant to be a temporary position became Alexander's new field of interest, opening him up to the world of bacteriology. In the inoculation department, researchers focused on developing vaccines, studying immune response, investigating bacterial infections, and creating therapeutic serums. In this department, Alexander was greatly influenced by Sir Arthur Edward Wright, who was a bacteriologist and immunologist. Germ theory at this time was still relatively young, so their collaborative work in the field of bacteriology and manipulation of the immune system to prevent disease would prove to be revolutionary. During World War I, Fleming served in the Royal Army Medical Corps and worked as a bacteriologist studying wound infection in a makeshift lab created by Wright in Boulogne, France. Here, Fleming discovered the antiseptics commonly used in wounds were doing more harm than good and urged others that wounds should be kept clean with mild saline. After the war, Fleming returned to St. Mary's in 1918 and was promoted to assistant director of the inoculation department. He would then become a professor of bacteriology in 1928 and later succeed Wright as principal of the department in 1946, which was renamed the Wright-Fleming Institute. One of Fleming's first notable discoveries came about when he had a cold and a drop of his nasal mucus fell onto a culture plate of bacteria. Mixing the mucus with the bacteria, weeks later he noticed the bacteria was gone. This random experiment in 1921 led to Fleming's discovery of lysosomes, an enzyme present in the body fluids with mild antiseptic effects. This discovery is considered a significant contribution to human immune system research. Alexander Fleming was considered a master of treating boils caused by Staphylococcus aureus, and part of his research involved culturing this bacterium. Although this story has different variations, this is the one version that is most regarded to be true. One day, by accident, he left one of the petri dishes with staphylococcal bacteria on it uncovered and by an open window. With time, mold spores appeared on the petri dish, and Fleming saw that the bacteria around the mold were dying, or as he put it, going into lysis. Fleming's curiosity was sparked by this, and he isolated and cultured the mold growing on the petri dish. He was then able to identify the mold as being a part of the genus Penicillin and noted that it killed off gram-positive pathogens. He also found that it was not the mold itself that kills off gram-positive bacteria, but a liquid that is produced by the mold. He then named the mold liquid penicillin. Fleming believed he had discovered a natural topical antiseptic, even though there had been successful injections of penicillins into rabbits, and he also believed that penicillin killed gram-positive bacteria by lysing them. However, we now know that penicillin stops cell division. Fleming used penicillin to treat an eye infection in one of his colleagues, but did not include this accomplishment in his publication. Fleming's publication in the British Journal of Experimental Pathology in June of 1929 told his findings about penicillin, but he was not given much credit or attention. A dilemma he faced in his research was mass production. He could not figure out how to mass produce the mold liquid and was nearing retirement. Fleming did not have the chemistry background needed to make this happen, and he watched as his colleagues continued to fail in finding the solution. Up until this point, penicillin was produced on a small scale when requested. It was not until Howard Florey and Ernst Chain found interest in penicillin during the late 1930s that it was able to be mass-produced for use in World War II for wound care. Before World War II, the deadliest part of war was infection. A simple cut or minor burn could cost a soldier their life. Soldiers would often die from wounds that modern medicine would consider trivial. The race to mass-produce penicillin became a national priority, and in 1944, the Allies had produced enough penicillin to treat wounded soldiers. It is important to note that Alexander Fleming had little to no part in the development of penicillin into a drug, but he deserves the full credit for scientific discovery of penicillin. It is also important to bring up that different cultures, like Native Americans or Mayan priests, have been using mold to naturally treat disease for centuries, but up until this point, there was no foolproof way to treat infection. So, the introduction of a sort of miracle drug that could cure anything from an eye infection to a tooth abscess sparked the attention of the public. This sparked a penicillin craze during the 1940s and 50s. Penicillin was included in everything from toothpaste to lotion. In 1955, Fleming, Florey, and Chain went on to share the Nobel Peace Prize in Medicine or Physiology for creating the first antibiotic. Fleming became a sort of celebrity and was even given the title of the People's Microbiologist. He was then able to travel around the world doing interviews and lectures, but suddenly died in his home on March 11, 1955, due to a coronary thrombosis. Alexander Fleming's contribution to the world of biology on how we are now able to treat disease using antibiotics has continued to have a lasting impact today. While antibiotics are a good thing that helps keep humans and animals healthy, there are drawbacks to them as well. Overuse of antibiotics, as seen during the penicillin craze, has caused some bacteria to become resistant to some antibiotics. The bacteria MRSA has even become immune to all antibiotics and is now classified as a superbug and is one of the worst infections you can get. Overall, Alexander Fleming has forever changed the world of biology and medicine with his discovery of penicillin.